Hey there, it's Workbench for Workbench Quagmire, back with day 8 of our series on the Free Code Camp Python certification. Today we're going to be looking at understanding functions and scope. This is a theory section, so there'll be a lot of text and some quizzes here. It looks like we got, a lab in here, so we'll see how far we get. Hopefully we'll get through everything, but if not, we may break out this lab section to another day. So let's get started here with how do functions work in Python. Functions are reusable pieces of code that run when you call them. Many programming languages come with built-in functions that make it easier to get started. Python's no exception, and we've already covered some built-in functions like print in previous lessons. Another helpful built-in function is input, which lets you prompt the user for input. So here's our example. You have a variable. So we create the variable. We assign it the output or what is returned from the input function. So the input function is going to put what is your name on the terminal. So this is our argument for our input function. The user is going to reply to this, types collad, presses enter. And then the next line, we have another function, print, which we've covered before. And we're going to print the string, hello. That's our first argument. The comma breaks up our arguments, but it also puts spaces in our output. So it will say hello space name, or in this case, hello collad. So on the other hand, int converts a number, Boolean, or numeric string into an integer. So we saw that before. So print, which is a function, int, which is a function, and then our argument is 3.14. So this function is going to run with the argument 3.14. It's going to return 3, the integer 3, and then that integer 3 is going to be the argument for the print function. It works the same here for 42, true, and false. You can also write your own custom functions. To do that, you use the def keyword for define, followed by the name you want to give your function, a pair of parentheses, and a colon. Then on a new line, you'll write the code your function should run. The code the function runs is also referred to as the function's body. Here's an example of a custom function named hello that prints the string hello world to the terminal. So the keyword def, hello is the name of our function. The parentheses, we would put an argument here, like the int example above, but we don't need an argument for this one, so we can just leave it blank. And then a colon, this kind of marks the beginning of our block. And then within our function, we have another function that executes print with the argument hello world. So when we type, to run the function, you call it, and it's name followed by a pair of parentheses. So when we type hello, it outputs hello world. Is when you type hello and it executes, it goes down here and goes, oh, I need to print something. What do I need to print? I need to print hello world. And so that's how that works. So notice the indentation before print hello world. As you may recall in previous lessons, Python relies on indentation to determine which group of statements belongs together. These groups of statements are called code blocks. Here's another simple function that prints the sum of two numbers to the terminal. So we're going to define calculate sum, and then here we have two arguments, a and b. And then we are going to print a plus b. So if you remember from our discussion of print, when we put a plus b in here, first Python says, what is a plus b? Okay, a is a number and b is a number. I'm going to add them together, and then I'm going to print the result. You can see the function calculate sum has a and b in parentheses separated by a comma. Those are your parameters or arguments. Think of parameters as placeholder variables that act as slots for the values you pass into functions when you call them. To use parameters, you have to pass in arguments. Arguments are the values you pass to the function when you call it. Here's how to call calculate sum function to sum together the numbers 3 and 1. So you would just type calculate sum parentheses 3 comma 1. Notice the space here. This is just good practice, so it's readable. If you saw some of the stuff I did in the last lab or whatever, I try to make sure that there's some spacing between different parts of the code so it doesn't all run together. Um, it doesn't affect anything when it runs. It doesn't take longer or anything like that. It's easier to read. If you call a function without the correct number of arguments, you'll get a type error. So calculate sum with no arguments is type error, calculate sum missing 2 required positional arguments. So uh, functions also use a special return keyword to exit the function and return a value. If you don't explicitly use return, Python will return none by default. So here's an example. Define calculate sum, A and B again, print A plus B. My sum equals calculate sum 3, 1. So 3 and 1 together, 4. If we print my sum, you'll get none. So basically, this assigns, because we don't return anything out of calculate sum, and it automatically returns none. None is assigned to my sum, and that's why it prints there. You probably expect a 4, and I'd probably expect a 4 sometimes too if I forget, and just type it in and be like, hey, how come? Oh, none. I have to actually print, calculate, sum 3, 1. You can see that calculate sum function returns the sum of 3 and 1, or A and B, but does not return anything explicitly. So we assign its results to my sum. The value is actually none. To fix that, you use return keyword, and you would return A plus B, as you can see here in this example. And then you can print my sum, and you get 4. So, and you could print calculate. I was incorrect what I said up here. If you print calculate sum without the return statement, you're going to print none as well. So now calculate sum returns the sum of A and B, which gets stored in my sum. All right, that was a fast one. So here are our questions. What is the default return value of a function in Python? Well, we just said it's not 0, it's not an empty string, it's not false, it's none. What is the term for the placeholder variable in a function? It is a parameter, the keyword used to define a custom function in Python. It is not function, it's def, not function. All right, let's see if we got it. We got it. All right, what is scope in Python and how does it work? In Python, scope determines the point at which you can access a variable. It's what controls the lifetime of a variable and how it resolves in different parts of the code. To correctly determine scope, Python follows LEGB rule, which stands for the following: local scope, so variables defined in functions or classes; enclosing scope, variables defined in enclosing or nesting functions; global scope, variables defined at the top level of a module or file; and built-in scope are reserved names in Python for predefined functions, modules, keywords, and objects. So Python uses the LegB rule to resolve the scope of the variables in your program. We'll dive into each of these rules and get better understanding of the process. So local scope means that a variable declared inside a function or class can only be accessed within that function or class. So here's an example. We define a function called myFunction. It has no parameters. Inside of it, we declare a variable named myVariable and assign it the integer 10. We print myVariable, or the 10. In this case, myFunction has its own scope, which cannot be accessed from outside the function. Calling myfunc will output 10, but printing myVar outside the function will lead to a name error. So define myfunc variable, we assign the integer 10, print myVar. If we type myFunction in the terminal, it will return 10, it'll print 10. But if we print myVar, which is within this functional, it'll give a name error because that variable myVar only exists within this function. Enclosing scope means that the function that's nested inside of another function can access the variable of the function it's nested within. So here's an example, outer function. We define the variable MSG for message, assign it the integer hello there, and then within there, we define another function, inner function, and we print the message. And we call the inner function inside the outer function. And when we run the outer function, it will print hello there. In this example, the inner function can freely access the message variable defined in the outer function. However, note that the outer function cannot access variables defined within its nested functions. So here's an example of that. Our outer function, we define that message variable, hello there. We print res. What is res? We haven't even got there yet. So we define another function. We create the variable res for response, assign it the string how are you, and we print message. So this inner function, because we talked about the enclosing scope above, has access to this. It can print this. This res variable cannot be printed by the outer function because it's not created within its scope. The scope of the res variable is within this function. So if we run the inner function, it'll run this. And if we didn't have this print line up here, that would all run like it did before. But now we have an issue because when we run it now, there's a name error because the interpreter gets to here and it says, I have no idea what you're talking about here. Even though it's here, I don't have access to that variable because it's in a nested function. The nested functions have access to the outer functions, but the outer functions don't have access to the variables within the inner functions. So that's because the response is locally scoped to the inner function. Also notice the outer function tries to print the response before inner function is even called. One solution is to initialize response as an empty string in the enclosing scope, which is within outer function. Then the within inner function makes response a local variable within the non-local keyword. So here's the solution to the problem. So we create our outer function. We define our message variable. We define our response, but we make it empty. So now it's available in this outer function scope. So then we define the inner function, and then non-local, we say, hey, we want to work with this non-local variable. We assign it the string, how are you? We print the message variable, which the inner function has access to because here we are. It was already declared in the outer function. We call the inner function. And when we call the inner function, it puts the value, how are you, to the resulting function, and then you can print the result is accessible and modified. So the output is, hello there, how are you? So global scope refers to variables that are declared outside of any function or class, which can be accessed from anywhere in this program. Yes, my var can be accessed anywhere, even inside a function it's not defined in. So here we just, at the top of our file, we would declare my var, and then we'd have this this function here, and it could print my var. We don't have to give it as a argument to a parameter or anything here. It just already has access to it. So when you call show var, it will show the 100. And then if you print my var, which is basically what all the function does, you'll get the same result. So, and if you want to make the locally scoped variable defined inside a function globally accessible, you can use the global keyword. So we have my var. This is a global, my var1. This is a global variable with the integer 7 assigned to it. Then we have this function that we define called shows vars. Then we say, hey, I want to create this variable that's globally available, even though I'm inside here. And then my var2 equals the integer 10, or is assigned the integer 10. We can print both of these because the inner function, or this function here, has access to the global variable myvar1 as well as the variable it's defined within the function. And so when you run show vars, it'll print 7 and 10. myvar2 is now a global variable and can be accessed anywhere. So if you type print myvar2 outside this function, it is also going to print 10. You can use the global keyword to modify a global variable. So we have a myvar is assigned integer 10. It's a global variable. We define this change var. We use the keyword global with myvar, which allows modification of a global variable. And then myvar equals 20. So we change myvar, we call it, and then when we print myvar, it will be 20 instead of the 10 that we originally declared it within the global scope. Finally, built-in scopes refers to Python's built-in functions, modules, and keywords and are available anywhere in the program. So print string 45, we'll print 45, print type 3.414. So yeah, and so is instant string. These things are available anywhere. So what is the rule Python follows to determine the scope of a variable? Stack? Nope. Tree? No. Legby, local enclosing global built-in. And scope. It's cute. But we know the answer to this has legs, so it's Legby. What does non-local keyword do? Makes the variable global? No, it does not. Creates a new local variable. Yep. Prevents variable reassignment. Nope. It allows modifying a variable from an enclosing function. No. Which keyword can be used to modify a global variable in Python? We just saw it was global. It's not local. It's not static. It's non-local. Not non-local. Let's check our answers. Oh, I got it wrong. Non-local makes a variable global, I believe. Oh, probably this one here. Let's see. Hey, we got it finally. All right. Why did I go down there? Okay. I think that's going to be all we're going to do today. Yeah, we're going to call it there. Next time we'll do this build a discount calculator lab. So that'll be day, I believe 8. I've lost track here. So build a discount calculator lab next time. This is Workbench. Don't forget to like, subscribe, comment. See you then.